Hello everyone, this is Dr. P. Mahalakshmi, Assistant Professor, Department of Artificial Intelligence and Data Science. Today I'm going to give a lecture video about the subject Digital and Mobile Forensics. Subject code is CCS 343 Regulation 2020. So in this video we are going to see about Android forensics. It will be the fourth unit in the subject of digital and mobile forensics. In this Android forensics we are going to see about what is Android basics, key codes and ADB. It's nothing but Android debug bridge, rooting Android, boot process, file system, securities, tools, Android forensics based concepts. We are going to see about what are the forensics procedures are there, and what is the Android bridge, that is debug bridge, and Android only tools, dual use tools, Oxygen forensics, mobile edit, Android add, decompile. So first we are going to see about what is Android. So Android is nothing but it is a one of the open source and Linux based is a FOSS, that is free open source access software, Linux based OS for the mobile device such as smartphone and tablets computers. This Android was developed by the Open Handset Alliance led by Google and other companies. So the basic Android programming, and will also take you through some concepts, advanced concepts related to the Android application development. So simple terms, if you want to say, this is Android is a free open source operating system. It's owned by Google. So open source means anyone, anyone can take the raw code and modify it. That is, the source code is available on the net. Anyone can access the code and anyone can update based on their need. So here, and it is used on the hardware. It was launched commercially in the year of 2008 and is heavily based on Linux, a stable, secure operating system widely used on the computer servers. And here this Android offers unified approach to the applications development for the mobile devices. So before, Android developers had to write completely different versions of an app for every single phone brand. Android created a unified platform. It's nothing but a developer writes an app once and it can run on the Samsung, a Pixel or Motorola phone. So that is, it is write on developers write once, that is only one code. It will be work on the different platforms like Samsung, Pixel or Motorola phone. So the slide also give a quick history lessons mentioning early versions like Android 1.0 in the 2008 and Android 4.1 Jelly Bean. So the Jelly Bean is an incremental update but primary aim of improving the user interface both in the terms of functionality and performance. So Android is one of the software. And here next one is Android application. Simply, if you want to say in that Android application is usually developed in the Java language using the Android software development kit. So here, beautiful user interface. One is it contains the beautiful user interface, and second one is connectivity. Wi-Fi, Bluetooth, 4G and 5G. Here it's a beautiful connectivity, storage, SQLite database for saving the app setting, and media supports playing videos, musics and taking photos. Multitasking. So here the multitasking, multiple apps runs at the same time. So here in this diagram is saying that it's an open source and it is increased marketing, and here reduce the cost of the development, and is a rich development environment. So it's in the simple term based, we have to say it has a beautiful user interface, and here it is connectivity, storage, multi-support and multitasking. And this categories. So before we are going to see the categories, the Android software stack architecture in the simple terms. That's what I said. That here application, actually app, you said the context browser gains, and application framework, the tools and toolkits that app use the function like the window manager or location manager. Libraries, there is an engine room. It's contain code C, C++ code, and Linux kernel, the absolute foundation that manage the actual physical hardware, drives for the camera, screen, and memory and processor. So here the some Android applications, here many Android applications is there in the market. The top categories are here the activities, so some of the components is sports, lifestyle, food and drink, books, and business, utilities, finance, music, news. So these are the Android applications playing a vital role in the market. And here history of an Android. The code name Android range from that A to N currently, such as Astro, Blender, Cupcake, Donut, Eclair, Foreo, uh, gingerbread, bread, honeycomb, ice cream sandwich, jelly bean, Kit Kat, lollipop, and marshmallow. Let's understand that Android history is in the sequence. So that is what I listed here as an image. So this is what the history of the Android, and that's a platform versions. Here we saw that 6.0, that 5, that from the 1.1 to 6.0 at that application level, from the 1 to 25 now we have, and the version code basis whether it is belongs to honeycomb or ice cream or lollipop or Kit Kat or here cupcake, the based on that version code also I listed here in the diagram. And next one is what the main thing is booting process in computing. Booting is starting up a computer or computer appliance until it can be used. So here the steps for the Android boot process. First one is boot the read only memory. So here when you press the power button on a completely dead phone, a processor has no idea what an operating system is. It's run a tiny piece of the unchangeable code burned into the chip called as boot RAM. Its only job is to find the phone's internal storage and load the next program. That's what bootloader. Next steps, it will go to the bootloader. So bootloader is a small program that initializes the phone hardware memory. It check to see if the phone is secure and then load the Linux kernel into memory. And third step is what? The detailed bootloader function. Simple terms is nothing but the bootloader running into two phases, primary phases and secondary phases. A setup of the critical electrical components of a chip so that main operating system can actually run without crashing. And third one is what? Kernel execution. And here in this kernel execution, once the Linux kernel is loaded, it runs on the screen drivers, camera connections, audio system, and hardware storage. And once the hardware is ready, it starts very first software program and special process called init. That is what? Initialization. And next one, the zygote means the beginning of life. That's starting the brand, a new virtual engine for every app makes a phone very slow. To fix this, zygote set in the memory as preloaded. So it's instantly called as clones forks itself. That is allows app to open milliseconds instead of the seconds. And next one is what? System server. So here the system servers which turns on the core features like telephony, that is cell signal, battery tracking, Wi-Fi management. When everything is fully up and running in the memory, the system send out to the silent broadcast message is called action boot completed. That message will get it. So, and this is what that the step-by-step process that I explained. And the next one is, so this is what we have in this video. So we saw about this step-by-step process what we have in the Android boot process. The first step is boot ROM, bootloader, and the detailed bootloader functions and kernel functions, and in it initialization process, zygote process, and last one is system servers and boot completion. So here in this video we saw about that what are the basics of Android uh, Android 4 and 6 topic, and then what are the basics we have and about the Android, and Android versions we saw. And another one is here we have saw that architecture, and then this steps is very important for the Android boot process. Thank you. Remaining topics that we see in the future video. Thank you so much.